everyone. Good evening. I'm Pradeep. This is Sagar. We are going to explain about Wi-Fi HaLow. It's basically the fourth lane of Wi-Fi, mainly meant for IoT applications. In this session, we are going to cover three different things. Why Wi-Fi HaLow exists in first place, what is the problem that it is trying to solve, and where exactly it fits into the existing Wi-Fi ecosystem, and how it became fourth lane for Wi-Fi and mainly for the IoT applications. And we'll walk you through some of the field test results that we have done in partnership with Wireless Broadband Alliance. And lastly, we'll walk you through what MOS Micro is offering to make Wi-Fi HaLow products. Let's get started with the Wi-Fi ecosystem that you're all familiar with. You all know that three bands are there: 2.4, 5 gigahertz, and 6 gigahertz. For generations, Wi-Fi has been growing only in one direction, using wider channels and higher frequency bands, providing high throughput applications. But for the first time, one Wi-Fi generation has grown in a different direction. So it has grown to use narrower channel bandwidths like 1, 2, 4, and 8 megahertz channels in combination with lower frequency bands like 900 megahertz to provide very long range Wi-Fi, like up to 1 kilometer plus Wi-Fi range. And that is Wi-Fi HaLow, and that fits into the Wi-Fi ecosystem, providing the fourth lane, especially meant for IoT applications that requires lower throughput, which need a reliable connectivity at a longer range. But it comes with the same IP stack, same WPA3 security. It is part of the same Wi-Fi ecosystem that you are all familiar with. So basically, HaLow is extending the Wi-Fi ecosystem. It is not a new entity getting added. It's not a proprietary thing. So let's move on to the standards. So it is still part of 802.11 family that you're all familiar with. It is 11.8 standard. And also it is part of Wi-Fi Alliance certification. So you might have been familiar with Wi-Fi HaLow interoperability certification, like Wi-Fi 6, Wi-Fi 7 devices get certified. Same way, Wi-Fi HaLow products also can get certified by Wi-Fi Alliance. So the magic behind this long range is when you use the lower channel bandwidths, like 1 megahertz, 2 megahertz, and 4 megahertz, and 8 megahertz. When you combine that with the lower frequencies, that's when we'll be able to achieve 10x range, 100x area, and 1000x volumetric coverage. So quick look at Wi-Fi HaLow features. It provides 43 Mbps of phi rate, and then 1 kilometer plus range. And each AP can support up to 8,000 stations. And the BSS max idle period has been adjusted from 17 hours to 5 years so that IoT applications can be supported. And then the unique feature of HaLow is RAW. This is restricted access window. It gives control over the medium access to the access point. So that's how access point can support thousands of stations without much congestion. So AP will streamline the medium access, and then thousands of stations can still access the medium and send the data reliably without having to go through this congestion. Plus, it comes with all the familiar Wi-Fi features, WPA3 security, easy connect, and device provisioning protocol, DPP, and TWT and VSS coloring. One interesting fact about TWT is it was originally introduced in Wi-Fi HaLow, and then it was later inherited into Wi-Fi 6 with some extensions. So that way, Wi-Fi HaLow was leading the way, and then further standards adopted these features. A quick look at HaLow spectrum, which channels are available in which countries. If you see USA, Canada, Mexico, Brazil, Singapore, and all these countries have a good sizable spectrum, which can provide up 1 megahertz, 2 megahertz, and 4 megahertz, and 8 megahertz channels. Only Europe and India has very limited amount of spectrum. Europe has 1 and 2 megahertz channel support, but India has only 1 megahertz channel, and that too only three 1 megahertz channels are supported. Uh, Whereas, like we are going to walk you through some of the field test results that we have done in the USA that has the largest amount of spectrum. Uh, there's a spectrum which shows like 26 megahertz of spectrum is available. Comparison, this chart shows a 5 throughput versus range. Um, Wi-Fi 4 to 7 provides very high throughput, but it drops off at very short range. And then LoRa provides very small bandwidth, like 50 kbps of throughput, and but it provides up to 10 kilometers. And the Zigbee and Bluetooth provides low throughput at a short range. And Wi-Fi HaLow is what fills in this gap, which provides tens of Mbps at hundreds of meters of distance. This gives a number for each of these WAN technologies available. LoRaWAN gives 50 kbps, Wi-Sun 2.4. You see, Wi-Fi HaLow alone is, I mean, it stands out in this comparison, providing 40 plus Mbps, which can be used by streaming kind of applications, and any low latency IoT devices can make use of this Wi-Fi HaLow, which needs a longer range. The interesting characteristics of Wi-Fi HaLow is signal penetration. It is far, far superior than any of the existing Wi-Fi because it operates in lower frequency bands. So it has higher wavelengths, so it can have better penetration characteristics when it passes through these dense materials. So for example, here, if it at line of sight, it gives 1 kilometer, and 2.4 gives 100 meters, and 5 gigahertz gives 30 meters. And then if it passes through the concrete, the last example, it gives 2.4 drops to 20 meters from 100 meters, whereas Wi-Fi HaLow still can provide up to 500 meters. And 5 gigahertz is only up to 4 meters. And similarly, the other obstacles as well, Wi-Fi HaLow gives longer range because of its lower frequency. Sagar will walk you through the field test results.
Yeah, hi everyone. So far we have seen Wi-Fi HaLow and the standard behind it, and special unique features behind it, and what value it can provide to the Wi-Fi ecosystem. We have seen. Sorry. So let's see in the real field test results how much value it can provide. So what we have done is we have done some tests with in association with WBA across four different properties of four different sites in USA, and with our first generation chip, that is 6108. So and N8 and 1 mega channels. So and at every place of these properties, we have taken our UDP uplink throughput and measured the throughput and how much coverage it can give you in each of these properties. So let's see. So before we move on to the field test results, let me state you a quick data point on why outdoor connectivity matters. Because according to one of the survey report, so range is the main reason behind the 25% of the complaints raised by the customers, and major locations for these complaints are edge of the properties and garages and secondary buildings. This is where actually the security camera needs to be, and and which is not addressed by our existing Wi-Fi generations. So let's see how HaLow could fill this gap. So as you can see in the table, an average US home and a Wi-Fi 6 AP can give you a 65% coverage. As you see, as you go through down the table, the bigger the property size and bigger the coverage cap. Whereas HaLow can give you up to 100% in across all different properties. And this coverage changes what makes possible. And let's see this in a real world how it can really provide that full coverage. So this is one residential site where we have performed the test, and this total area is of 1.7 acres, and there is a 3-story building inside the property. Next, building inside the property, and this is the interior coverage. So we have placed our access point in the first floor, and its max, it could give max of 22 mbps, and it was able to provide 22 mbps at in the first floor. And at the same time, we have measured the UDP throughput at basement and the second floor. As you can see, minimum we observed was 8 mbps in one corner of the second floor. So this is more than enough for an HD camera to stream uninterruptedly without any interruption or any kind of buffering. So next, this is the exterior coverage, and the AP placement is not changed. So, and we measure this throughput at every corner of the property. You can see all the edges. We have placed the devices and measure the throughput, and the minimum that throughput that we observed is 5 Mbps. Again, typically when HD camera takes around requires around 4 Mbps or at max 5. So which is again enough for a HD camera to stream without any connectivity or buffering. So, and with this, what happens is you can place an AP inside the home. Still, you can place a camera outside your home, even at the edges of the property. So, this is just a residential proof that HaLow can give you 100% coverage in a residential property. So, this coverage changes what it can what is possible in the Wi-Fi ecosystem. So, and especially at the same time, we have placed 8 cameras in different places of the properties, and uh, all these cameras could stream without buffering, as you can see in this, without any connectivity issues. Continuously, we have placed this for under 24 hours. It all was streaming without any buffering. And at the same time, we placed additional devices at different places just to simulate in a smart home. And all these devices could, around 15 devices was there, all 15 devices could connect simultaneously without any issue. And at the end of the testing, there were 23 actively running devices, including those 8 streaming cameras. So it has covered entire property, including the edges of the property, even the like it could you can come up with a another smart various kind of smart home controllers, like say let's say as seen in the picture. So there are a lot of IoT devices today sits outside the range of the Wi-Fi network. Let's take a perimeter camera or a fountain controller, temperature or humidity controller, or even EV charger. So all these devices today are outside the coverage of the Wi-Fi 6 AP. If you can add this HaLow to your Wi-Fi 6 AP, so it brings all these devices into the same Wi-Fi ecosystem, which are not part of the Wi-Fi ecosystem earlier. It doesn't need it joins the same IP stack, same WPA thread security, and then just HaLow is the one that is making possible, and this is mainly on the residential property. Next, it's a slightly different environment. And it is a working warehouse. It's an operational one. So it is total area of 30,000 square feet. It had around 20 double-sided racks. We have tested with the same device, and and the existing operational site had 42.4 gigahertz APs placed to give the full coverage to the entire area. So, but still they had one device which is critical to their operation. So it had some connectivity problems at corners of this warehouse. So what we did is we placed an HaLow AP, see if it can address this connectivity problem experienced by their critical device. So, and this is the coverage it could give in the interior of the property. So, the minimum it could offer is 2.1 Mbps. So, which is enough for the device to operate without any connectivity issues or without any, without any rolling back. Because the device that they were using is mounted on a forklift. Any connectivity problem, they have to move back and then come to the range of an AP, then connect back. So that was very difficult. So, but with HaLow, it could cover the entire property. And the device had no connectivity issues. In the same warehouse, we placed cameras in different places, and all these 9 cameras could stream without any interruption. And at the same, yeah, this is what HaLow can do for you. All the different IoT applications, like a smart parking monitor or a perimeter sensors, a smart lighting, which usually will not have a proper Wi-Fi coverage. Now we can bring them into the same Wi-Fi coverage, and it adds more devices to the same ecosystem. Yeah, this is the third site where we have performed our test. This is a smart field. This is of total areas of 7.3 acres. So it had 4 greenhouses plus couple of warehouse and general stores. And so we have placed our AP in one of the warehouse, outside the warehouse, and then we measured the coverage and throughput at different places of the warehouses. And the minimum it could, as you can see, minimum it could provide was 4.1 Mbps in one of the greenhouses. Again, which is enough for any IoT application in an agricultural site. This 4.1 Mbps, what you're seeing is one of the greenhouse where agriculture site. This is more than enough. And at the same time, we placed 7 different security cameras at different places. They were monitoring the crops, livestock, and then security equipment. All these places they could monitor easily with one single HaLow camera. And last site, which is the most interesting thing, is the smart city. So this is mainly tested in a 1 megahertz channel. So this is the narrowest channel available in the HaLow. This is to test 2 characteristics of the HaLow. What is the range it could provide? At the same time, what is the area coverage it can provide you in a smart city. So we have placed an AP 12 meters above the ground just to simulate a traffic pole and see how much coverage can give. As you can see in the picture, it could give you it could give you a 2.4 kilometers of line of sight coverage, and then it could give you a 600 feet of diameters coverage. It could give you. At the same time, at any point you take in this map, it can give you at least 150 Mbps. Even at minus 90 dBm, it was able to give you 150 kbps throughput, which is again enough for an IoT application. Interesting thing part of this is this place had different multi-story car parking places, which is of metal structures and smart this concrete buildings. It can penetrate through all these things and give you that 600 feet coverage around the chip. So it could very well cover all different IoT applications.
Yeah, before we move on to other section, Candler has done one test which proves exactly these claims. All these 4 tests are done in partnership with Wireless Broadband Alliance. And in the similar line of smart city application, Candler has done one test. We'll just play that short video. Provided around 2.6 kilometers, exactly mapping to what Wireless Broadband Alliance test has shown that 2.4 kilometers and this 2.6 kilometers. Thank you, Kendra, for confirming our claims.
Yeah, let me walk you through some of our HaLow solutions. We have 2 generations of chips, and one is 6108, one is 8108. Both provides you SDO and SPA interfaces. but our second generation chipset provides an extra USB interface. So this is our second generation chipset, and usually this transmit power efficiency of the any Wi-Fi chip you take it in the industry, it gives you around 6 to 12% of the transmit power efficiency. But whereas our second generation chipset, it can give you a 37% efficiency. That is, for the same amount of RF output, it consumes 75% less power, and at the same time, it can give you more longer the battery life. It can play very so it can play a very huge role in the smart metering applications where today they run on a battery where you need to charge the battery for every 2 3 years. The same it can give you the battery life as long as this meter life. And these are the some of the evaluation kits which are available in our my site. You can avail even through mouser.com. So,
We have also a design partner program, and it's a complete ecosystem that we are trying to build. Uh, Please do talk to us if you are interested. HaLow is not here to compete with Wi-Fi; it is to complete the Wi-Fi ecosystem. Thank you.
Thanks. Since you're probably running a little late and you have booth, so I would maybe ask you people who are interested maybe to come to the booth also and talk to you.
Yes.
So thanks, Morse Micro team.